Hello everyone, what's up? What's going on? So today we're going to be doing some OpenCV projects, very basic, very simple, beginner level. So we'll start off with just opening and reading images and going down to background removal, face detection, Canny edge detection, Sift algorithm. So we'll start off with the basics, and this is all coded in Python, and then we'll gradually go into the more higher level. So the idea is to have 7 projects that you can do it over a weekend just to get your OpenCV up and running so that you can start practicing the higher level projects. So if you want to stick around with me, and I'm going to be going back into my OpenCV projects, and we'll start for reading into those and doing some more complicated stuff. But right now we're going to start with the beginners level. These quick 7 projects will help you getting a basic understanding of what OpenCV is, and it will gain some sort of fundamentals that you can use in order to make some better projects and where you can make some real world applications. So without much, let's go into it. I have 7 projects opened up here. So the first would be just opening up the image and resizing, and you'll see the program starts from here. So it's going to be reading this image called color JPG. You want to make sure you're importing CV2 in all your projects. CV2 is the library which OpenCV runs on, and imread cv2.imread is basically the command to read the image, and it stores under the variable called img. And when you put cv2 imshow original image comma img, this makes it display on a window, and we can call the window named original image. Here I have a bunch of other other functions going on. So I'm putting down resize, and img is equal to resize img 60. So what I'm doing down here is I'm downscaling the image by 60%, and how I'm doing this is based on this function which I've defined here. Define resize img scale percent. So the width is the original width of the image. The original width of the image is given by img.shape, and I'm multiplying that by the scale percentage amount. So I'm 60% divided by 100. So we're going to be downscaling it by 0.6 times. So the width would be changed accordingly, the height would be changed accordingly, and the new dimensions is this width by height. And you're giving this command to the resize function of OpenCV. It's run by cv2.resize, and you'll see you're giving the original image, which is img here, which comes from this variable, and the new dimension which we defined earlier here, and interpolation. So OpenCV has a couple of types of interpolation. This is basically you're defining how or on what properties the resize function should operate. In this case, we have defined it should be uniform across the entire area. And then I'm just printing down the new dimensions for reference, and it's going to be called under resized shape. Notice when we were calling img.shape and giving the array variable 1, it was just taking the width function, and here it's going to take the height function. But when we have resized shape, it's going to print both the width and the shape, and it will just return the resized new image to this function back here. I'm going to play this again, and I'm going to show this, and I'm just calling this window name by scaled down by 60%. So it's going to open a new window, and it should display this word called scaled down by 60%, and hopefully the image with that comes up would be downscaled by 60%. Same case here, I'm resizing the image again, but I'm doing it by 20%, and I can notice I made a mistake here. So I wanted to put down upscaled here, but this is again downscale, scaled down by 20%, and I'm just saving this file. Now this is one of the important functions. I don't know why, but cv2.waitKey, this is an essential function. If we don't have this, for some reason the imshow function doesn't work. This was a case, this is a case which is going on for a long time, but people have got used to working with it. So cv2.wait key, make sure you're entering that as the last portion of your project. And without this, the IAmShow function where you're displaying the image will not work. And once that's done, it's going to wait for the escape button, or something to close the program. And at that point, you want to destroy all the images, all the windows, so you're not using any more memory, unnecessary memory. So you're coming back here. This is the folder where I have all the projects saved, and I'm going to right click, open terminal, and the first step you want to do is open the virtual environment where you're running this. In my case, I already have a virtual environment, and I'm calling this under the folder virtual environment OpenCV, and it's under the bin folder and the folder name, and we want to run this program called activate here. So you're coming back, let's go back to the original folder where we have all the projects, and let's run command line. We are under the basics folder, so we want to come back and open the virtual environment folder. So we're going to write source virtual environment bin, I'm simply OpenCV bin activate. So the moment I do that, it's under the virtual environment OpenCV. For those of you who want to know how to install or how to run the virtual environment, you go to my previous video where I've explained how to use the virtual environment and why we are using the virtual environment. Once you're inside the virtual environment, you want to make sure you're installing OpenCV, which is pip install Python OpenCV. I believe it's Python OpenCV or OpenCV Python. Let's do the other way around. I believe it's Python OpenCV. I already have it installed, but we're going to just run it quickly to see if it's working. So it looks like it's not working. I was wrong. I get confused with this. I'm sorry. So it's going to be OpenCV -Python. So in my case, it says that it's already satisfied because it's already installed here. But in your case, you'll have to install this. It's an easy install. If you just click pip install, then it should go ahead. So we're back here, and we're going to run the first project, which is Python OpenImage. And the moment we do that, we see it's scaled down by 20%, scaled down by 60%, and that was the original image. So you get the idea. That's what it's doing. Simple, just to read and resize the images. Once we're done with this, we close it and we go back. So now down to the second project. This is the Canny edge detection, and this is an edge detector, which I believe the scientist name was something related to the word Canny, and they had defined, or they had designed this edge detection algorithm. So what it does is, the first step you want to do is you're making sure you're importing CV2 and NumPy, and in order to install NumPy, you just go in, click pip install NumPy. In my case, I already have it installed, but it will look a little different for you. And just make sure you're installing NumPy and then importing NumPy and CV2 OpenCV in this project as well. Here I'm defining a variable called cap, and it's calling under CV2 video capture 0. So this is basically calling my webcam, and I'm giving the webcam the number 0. So this is my laptop's the default webcam, and it's going to open that in order to run this. So I'll say cap is equal to cv2.video capture. So this will define my webcam, and I'm calling infinite loop while 1, and this is frame cap.read. So this is the function in order to read the frames from every frame from your video camera. So your webcam, it's basically you look at it up I mean, you look up your webcam as a video defined, it's giving out videos, but OpenCV reads it as an image. So every frame which you can see on your webcam is basically an image. So a video is nothing but a sequence of images which are displayed one after the other after a regular interval of time. So OpenCV reads it as an image, and you want to define that by giving frame equal to cap.read. Notice this comma here, this is just a flag which OpenCV provides if you want to see whether the frame was read or not. In our case, I'm not using it, but as long as you put down frame, this function equal to cap.read, it'll read the frame from your webcam. Changing the color from color BGR to HSV. So this is from the regular the blue, green, red, and I'm changing it to hue, saturation, and variance. The reason we do that is by providing HSV, by just changing the hue value, you can change the color, whereas with BGR you have to play with three different variables, three different matrices. So you want to be it's easier for processing, and hence for that purpose we change it from BGR to HSV. And once we do that, we provide HSV. Here I'm looking for a particular color, 30, 150, and these are just variable values. So we're defining that the lower red and the upper red is so and so area, and I'm just defining the range of the color which I'm looking for, and I'm using NumPy array here, and these are the variables that we are defining. So the color is defined by 30, 150, 50. So anything that comes under the range of these two colors, 30, 150, 50, and 25, 25, 180, would be basically captured and then given as a mask to this variable. So you're using in range again, and this is just to find out the whatever that comes under this color radius. You're using that, and you want to make a mask out of it. So you're not taking the whole picture, but you're confining yourself to that that region of interest which is defined by this color value, and you're using in range for that. You're providing the color range, lower red and upper red, and it immediately gives out the mask. Then you provide the resolution, and the result basically, the result is provided by CV2 bitwise AND. So what I'm doing is you're using the frame, you're giving the original frame, and you want the result also the frame, and you're giving the mask which is from the previous function. So what we're doing here is we are providing the mask, and we want the original frame to be extracted out using that mask, the region of interest which you had defined using the color variable. Once you do that, you want to show the original frame, and you want to show the edges frame. The edges frame is defined by the Canny edge detector. Now this is the main part of the project. This is the main file, and this is what we're doing, and that's the reason we did everything on the top. But this is the main Canny edge detector function, and OpenCV has a simple function, and if you call it by cv2.canny, the frame, and you're providing the variables for the Canny function to work, and it will return you a edges file, and it will show, you can show it by using the imShow function. We're going to give the window name edges, and here I'm providing the weight key. Notice previously we had used CV weight key 0. Here we're going to be using CV weight key 5. This is just giving a time variable, and you want to also make sure it's 27, which is the escape function, and the escape button on your keyboard basically. Once you're done with that, you're destroying all the windows, but you're also releasing the cap, and the cap, remember, this is what was holding your webcam, so you want to release that so that your webcam is available for other functions or other projects. We'll come back and we'll run Python to Canny, and the moment we run that, you'll see the edges file has opened up. This is my original file, and you can see it's a real time. I'm talking, and it's working out seamlessly. I'm running on a very low powered laptop, but still the variables are, the processing is pretty fast, and you can see it's able to track all my motions. So that's good. We'll go back to the next project, and I'm going to press the escape button here. So down to the third. This is a simple application. I should have put down Canny edge detection as one of the end projects, but let's go into the blur. Blur is easy. You're using video capture, and again you're using your webcam, and you're calling it from the variable cap, and you are using infinite loop while true, and we're using frame equal to cap dot read. Again, this is the flag which we in the previous project we didn't define, but it doesn't matter. Blur, now this is the function which we are using in this case. What blur does is it's a Gaussian blur, and it's going to be simply doing a smooth blur on your image, and we're defining the image by giving the frame, and 5 by 5 is the window size of that Gaussian blur which we're going to be using. So the OpenCV is going to use a 5 by 5 filter, and it will pass through the whole image from column to column, row to row, and then it will go and clean all the image using that blur function. And the moment it does that, it goes into IM show. You're just going to be reading the original frame, and you're going to just go and show the blurred image. Once this is done, again the same key, same purpose, where we use the cv.wait key. Notice that it's an essential function no matter what project you're using, but in order to display the project, display the image, you want to use cv.wait key, and it won't work without that. And again, once everything is done, we're just releasing the webcam so it can be used for other projects, and here we're destroying all the windows. Let's go back and run this project, Python 3 blur, and you'll see this is the blurred image, and this is the original image from the webcam. So you can notice the difference. You can see how blurry this is and how smoothly it is done over the whole image. So this is done. This can be used for several projects. It's used for different types of edge detecting, and where you want to erode certain variables, where you don't want to be a certain region or mask, and you can define the blur function over there. So once we are done, we close it by pressing the button Q or the escape, and next go into the fourth project for today, and this is going to be the rotate project, and you'll see the rotate function is defined here. I'm just giving the variable image, which uses the frame, and then you define the rows and columns. Rows and columns is nothing but the width and height, and the reason we are providing that is by giving im.shape and array2. So im.shape houses all the information about the size and shape and the dimensions and the width of the image, and it basically provides 4 arrays, but we're using the rows and columns. The reason we are doing that is we want to define the center point where we are going to be rotating. So we are going to be rotating the image, but we want to define, or we want to show OpenCV how we should be rotating it. Should it be rotating it from the center, or should it be rotating it from the edges? So that's how you want to define where the center point of that rotation is. Is it rotating from the edge? Is it rotating from this edge, or is it from the center? So you want to define where you're trying to rotate the image from. In our case, I wanted to rotate it from the center, and you're giving the center of the matrix, the center of the row, defined by the columns by 2 and rows by 2, and you're defining it that it should rotate by 90 degrees. Once we define all this, we give it to the wrap affine, and this is the guy which is going to be rotating the image by the rotation matrix information you gave here by M, and using the columns and rows which you found originally. And it saves under destination image, and the destination image is then returned to your main project. You come here, you're initially reading the color image. In my case, I noticed that the height, the width and the height was a little different, and I wanted to make the image square, so I'm using this. For your case, you don't need to worry about this, but I wanted to give that effect of rotation, so it looks like it's rotating, and for that purpose I changed my original image, which was the color.jpg. This was a horizontal image and I wanted to make it a square. For that purpose I changed the height to 476 because the width was 476, so I changed that so that it looks a square, so when it rotates it looks seamless. But for your case you don't need to worry about it. I just used it for this purpose of display. And then you're resizing this image by giving the dimensions I had given, which was 476 and the original width of the image. And I'm again changing it by using the area, and it's just displaying the image dimensions for me. This is the main project which is going to be rotating the image for us, and it's again going to be a infinite loop. And I have image is equal to rotate image and cv2 imshow rotate image. So I'm calling this function which rotates the image and saves it in the same variable image, and I'm rotating it, and again I'm using the cv.wait function so that it displays the image on the window, which is good. Let's go back and for.rotate. So you'll see that it's rotating now, and it's giving that effect where it's rotating continuously. I gave it notice I gave a delay here, cv.wait key 300. So for every 300 microseconds it's going to be rotating, and we're giving that delay so that it looks a seamless effect. If I had put it a little faster, then it would be very fast. So if you reduce the delay time, then the image would be rotating faster. That's the whole purpose. And once we are done, we press the escape button and we are out of the project. If you have any doubts with these projects, if you feel I missed something or I should have looked different, or you need more explanation, leave a comment below and I'll be happy to explain it to you. Next project is going to be the face detection, and this is what most people get excited about, but it's nothing too complicated. And once you know how this is done, it's going to be very simple. Here again we are going to be importing NumPy and CV2. Face cascade classifier. So this is the main thing, this is the main guy which is going to be helping us detecting these faces. So this is basically a cascade file, and we have it under frontal face default XML. You'll see it here. The file should be here, har cascade frontal face. This is nothing but a file which houses all the information about how a face looks like. So how our cheeks look like, how the shape of the face comes up. So this file, it's a machine learning algorithm, of course, and it has saved, and it has taken up many images and identified how a face looks like, and it has saved all that information in terms of numbers in this file. So now we can use that classifier in order to find where an image looks like a face. So this is a very fast classifier compared to the neural networks and the other more higher based on TensorFlow and all. But this is very simple, very easy. It runs on a simple camera or the old smartphones. So it's very easy, very fast run. Of course it doesn't house many more complicated functions, but for our purpose, just to detect a face, it's good. And we're going to be calling it by using the Cascade classifier, and we're saving it into the folder, into the variable called face cascade. We come here, We are using video capture to so that we can read our webcam, and we are again opening up a infinite loop. We are reading the image using the cap.read function, and we are saving it in another variable called image. Here I'm changing it to the gray value. See, convert color BGR to gray. In the past we had used for Canny we had used BGR to HSV, but here in terms of our face detection we're changing it to BGR to gray. And the reason we give that is so that we can give the grayscale function, which has no color definition, to your face cascade, because that's how the face cascade was originally created. You're changing and you're giving the faces, and you're detecting faces by using the face cascade and multi-scale detection, and you're giving the gray, and this is the filter value, this is the filter size, the window size which you're providing it for the Cascade classifier. Once it's done, it saves all the information about the faces that it has detected in this variable of faces, and faces is nothing but the the initial coordinates, the x and y coordinates, and the width and the height of your face. This is all saved in this variable under faces, and for a number of faces it has found out. We're just going to call cv2.rectangle img. This is I'm just drawing a rectangle over the face when it's detected, and it's going to be drawn on this image img. It's going to start at the x and y location of your image of your face, and the rectangle function not only needs the initial coordinate, but it also needs the amount of width and the amount of height from that point. So you want to define xw. X plus w is going to be the width, x plus y plus h would be the height. So you're providing it in this way, and this is the color. I've provided 0, 22, 55, 0. I believe it's yellow color, yellow or green color. So it's just defining the color of the line which is going to be used for defining the face, and the number 3 is nothing but the thickness of the line. And once everything is done, you want to show the face you want to show the image with the face by using this face detector, and again you're using the wait key function just to display the image. Everything is done. We release and destroy all the windows. We'll come here, we'll say Python 5 face detection. So we're in the face the 5th project, and you see the face detection is working. And if I remove my glasses and if I put my glasses, it doesn't affect, it's able to detect. So and you'll see it's pretty fast. I'm moving it seamlessly, and it's running. And the moment if I go out of the frame and if my head is tilted, then it loses me. But if I have a straight face, it's pretty good. So this functions. Let me see if I can find another face so that we can detect. I can see a Tony Robbins book here. Let's see if it helps detecting. So it is detecting Tony Robbins, and let's see if it can detect both of us in the same frame. Oh, okay, so it's doing, and you can see how it's able to detect both the faces in the same frame, and it's pretty fast. So with that, we're done with the face detector, and we're also done with 5 Python projects with OpenCV, which is good. I'm going to put all these projects in the description below on a GitHub soon. The 6th project is my favorite, and this is the background removal project. It's going to be a little longer for me to go over this, but I'll try to explain as much as I can. We're using 3 different libraries here: CV2, NumPy, and Sys. This is just a resize function, and I'm just providing I'm not going to be using the resize function here. This function we don't need here, so we don't need to worry about this. I think I can safely delete this so that it makes things simpler for us. I believe I was using resize here, and I'm not going to use it here, so we can extract that. Let's delete all these things so to make things simpler for us. Anything else that we don't need? I guess this is working. Okay. Alright, so this seems to be fine. We're simply reading the video capture, the webcam here, and we're going to be reading the webcam by using the video.read command, and it's going to save into the first image. The first image is what I'm storing into the reference image. So background removal is nothing but subtracting the foreground with the background. So what you see behind is basically the background, but me in front of the wall is nothing but the foreground. So we want to subtract me, which is the foreground, from this background. And for that purpose, you want to save the background. You want to show the webcam how the background looks like. So that's the background, and you want to save that background into an image, so that whenever a foreground comes in front of it, so this is a foreground, this is a foreground, and whenever these foregrounds come in front of the background, you can subtract these guys from the background image and basically give you the background subtraction for, the effect. So this is in-house self-made background subtraction algorithm. This is not used this is not using the OpenCV inbuilt background subtracting module, so it will look a little complicated, but OpenCV has very simple background subtraction functions which you can easily use. I'm just using the reference image, video.read, and once I'm coming here, I'm opening the infinite loop of while, and I'm again reading the read with the video. Oh, sorry, only if I can talk. So I'm opening the video.read, and I'm saving it under the image variable, and we're calling it as if flag equal to double equal to 0. Reference image is image. Now what I'm doing here is I have a function written here, D and R, if you see on the bottom. So what I'm doing is I want to save the background. I want every time I want to define what my background is. So when I press the word D, it's going to capture the background, and it's going to show the program that this is what my background is. So when I press the button D on my keyboard, it will define what the background is. And when I press R, it will start recapturing it. It will start subtracting the background. So that's why I'm using this, and I'm using this flag function just to define and I'm saving that background in this ref image, which is the reference image, but nothing but the background image. And I'm subtracting here. So I'm subtracting first image and with the reference image with the background image, and I'm subtracting the ref image with the background image. So, and I'm adding the differences so that I know where all the issues are happening, and wherever the difference is less than 13, the absolute value, so this is my threshold, wherever the difference is less than 13, it should make it 0, and once it's made 0, then we are converting it into a gray value. We are also giving it a foreground mask, and that mask is defined by whatever which is given, whatever part of the image which is 0. So to make it simpler, what I'm doing is I'm taking the background image, and I'm taking the foreground image. I'm subtracting both of them, and wherever the difference lies in those images, and I'm creating a mask around it. So whatever the differences are between this, it will create a mask by putting black color instead. You'll see when we run the program, you'll see the difference, that wherever the background is, it will define it with the color black color, and we are defining it by giving the foreground mask here. Once the foreground mask is created, you want to subtract that with the original image. So I'm doing that by using bitwise AND, which is nothing but wherever the mask is overlaying on the image, it's not going to process that part. But wherever the mask is not there, then it's going to give you the original image. And we're using the bitwise AND for this purpose, and I'm using the foreground mask to define it. And once it's done, it saves under the foreground image. These two functions I've used just to make it more seamless, and I've eroded all the the differences wherever there is noise. Small background subtraction is not a very a seamless process. It has a lot of noise involved in it in the background, and we don't want that noise. We know our foreground. So in my case, I am the foreground, and I'm a big body in front of the image. So there's no way that noise or the patches of these pixels which come out in the background are going to be small. So for that purpose, I'm eroding all the noise that would arise if in a normal way. And that's the reason I'm doing that. You can test this project by just by commenting this. You'll see what's the difference between eroded and this. But we don't want to do that. We don't want to make this video long. If you have special interest in that, let me know, and I'll make a separate video for this. Once we're done with everything, we show it under IMShow, and again the CV weight key. This is something which I'm using just to capture my background, and at the end we're just destroying and releasing. So let's come here, Python 6 background removal. So it looks like it's the edges function is there, and I'm going to be moving away from the frame for now so that it can capture the background, and I'm going to try to come in front. So you'll see the background is now running, and it has detected me. There's still some noise here around my hand and around my collar. So you'll see the difference. You'll see how the background subtraction is running, and if I move away from the webcam, it's good. But if I come closer to the webcam, then the background subtraction algorithm fully messes up. And the reason for that is it's not with the algorithm, but with the webcam that I'm using, because every webcam or every camera has its own self-automated correction. So the moment I come closer, what happens is the brightness around increases. So the camera tries to adjust by increasing the brightness or the contrast or the saturation. For that purpose, it causes a lot of noise and a lot of effect. That's the reason when I'm away from the webcam, it's working very nicely. But if I come closer, you'll see the difference, and you'll see the background subtraction not working properly. But this is good if you're staying away from the webcam, and if you know, then why to worry about it. So, but if this can be removed, if we remove that automated self subtraction from your webcam, then it should be fine. We're done with this. We press the escape button now, and we are out of the project, and we come down to the last project for today, and that's going to be the Sift detection algorithm. This is nothing but a template matching algorithm. It's a very fast Sift detection. So it's a speed foreground estimation. What it does is if you provide a template, if you provide an image, and if you try to ask, and if you ask for where that image is, so it's nothing but an object detector, a very fast object detector. And in our case, what I'm doing is I have used these Pringle boxes. So this is one image, the Pringle box, and this is the other image, and I want to find where this Pringles box is in this image. I mean, we can see it, but we want to see how the project finds out. So I'm providing the template under this file img1, and this is the main image where it's going to be looking for, and we're just creating this orb create, and this is all part of this all 4 lines is used for the Sift algorithm, and we're using that in order to create the ORB detector. and we're going to be computing all the necessary values from the img1 and the img2, and we're saving it under the kp1 and destination folders. These are nothing but Sift variables that are going to be used by the Sift algorithm here. And we're creating this Sift algorithm matcher. This is nothing but the algorithm which the Sift uses in order to, there are different types, and we are defining this by normal hamming, and we're defining the differences, and we want to use that BF match using the two destinations, and we're going to be defining the matches by the distance between them. Once all is done, we draw these we draw whatever the points are where the template and the original image matches. We're going to be showing that what are those points where the original image and the template image are matching. So we're going to be doing that by running Python 7 Sift detection. You'll see it's pretty okay. We can see there are points where it's trying to identify the logo because this is a different box. This is a red color original box, and this is the different, I don't know what it is, if only if I can read it, but this is what it does. It's only defining, and it's not the best, but it does the job okay for us. You'll see this for part of the logo, for some reason it is trying to locate it in this part of the image, which is not good. But for most of it, it provides the information of where the image is, and that's what is more important. So how good your algorithm is, or how much error it has, and then we work slowly towards it. OpenCV is all about finding the errors and then working towards minimizing it so that it is reasonably accepted in order to use it in a full-blown functional program. So with that, we come to the end of this video. If you like it, do subscribe to my channel, and if you like to see more such videos, I'm going to be continuing on this. We're going to be doing OpenCV, Flask, IoT, AI, machine learning, everything involved. This is my way of teaching myself and understanding the algorithms better, doing it more better in a more so this is my practice playground, and if you want to join along, subscribe with me. So till then, have a good day, stay safe, bye bye.